to the Todd and Noah Show, taking the mystery out of electric motors. Once
it's
again,
almost October.
Got Noah Bethel with me, VP of Product Development.
And hello from sunny Tampa, Florida, broadcasting from
Sunny Florida, Fort Myers area.
sunny Fort Myers.
Off Cape Coral Boulevard.
Cape Coral area, yes.
Or Parkway, one of the two. Lafayette.
Yes.
We've got another, this is going to be a 6-part series on reviewing case studies, a forensic review or a deep dive of the Rotor Bar Case Studies is what we're going to focus on today.
Sounds like a TV series.
I'm going to try and get somebody to fund us the cash so that we can put this on. It should be, at a minimum, so maybe NPR.
Maybe 5 seasons.
Maybe NPR. I don't know. I'm not sure we make it to the big networks, but NPR is always looking to help out individuals, and this is more technical in nature. So, Noah. Our first case study here is interesting because it's actually incorporating our latest technology that's coming out.
We're so excited about the PDMA.
Yeah.
The eye, basically keeping an eye on your motor 24 hours a day.
Yeah, and if you listen to one of our podcasts, which was the tips area where we did 6 tips, right, where we focused on rotor, stator, air gap, power circuit, power quality, insulation. But the rotor aspect of it, you mentioned one of your most favorite tests was startup. So with this technology, we never miss a startup now, correct?
It's like a dream come true.
For you,
literally, it's going to capture every inrush.
Yeah.
And so you'll have access to look at every start that the motor went through.
Right. The most difficult time for an asset,
high stress.
You're now going to be able to collect that information.
Absolutely. Not just the inrush peak, the raw peak, the startup duration, all this stuff, very critical. And to be able to alert someone that, hey, you just doubled your start time is such a big deal.
So quick refresher, what were the 6 methodologies that we could test for rotor bars?
So a quick review. Yeah, we've got the rotor influence check. We got the average inductance. We've got, of course, my favorite, the inrush startup.
Okay.
You've got the pole pass amplitude in the spectral peak. You've got the pole pass in DMOD. Was that 5? And then finally, you
had pole pass and DMOD. You had pole pass and DMOD. You had fifth harmonic.
That was it. The fifth harmonic.
Fifth harmonic.
The swirl effect.
Okay, swirl effect was the 6th one.
That's right.
That you can utilize for any type. And most of those, with the exception of the RIC, can be found with the PDMAI, right? Because the rotor influence check is an offline test.
RIC is an offline test, right? So, there's certainly...
And average inductance.
So
there's 4 methodologies that we can use with the PDMAI.
4 running directly applied to the PDMAI and 2 with the offline MCE required. The PDMAI is and this, what was nice is this case study you're getting ready to jump into was one of the sites we started with the PDMAI, for years of beta testing, and it was what a great opportunity.
It was a great opportunity to hook it up and then be able to. Now we're trending it. And that's what because not all, if you see a rotor bar problem, you don't necessarily have to pull that asset, correct?
Well, you mentioned, in one of the tips, the rotor tips, talking about the birth certificate, right? Get the bar count, get the information. Was it open or closed bar design? All that goes into how quickly you need to react. So in
your
a situation,
decision-making changes.
Exactly, right.
Versus a 4-pole, 6-pole, 8-pole, or a 2-pole.
Right. If it's 2-pole, high centrifugal forces, you can't mess around. If it's 2-pole with an open bar design, which means there's a place for that rotor bar to come out and fly into the stator, you can't mess around. What's nice is we're be 1,000 miles away and look at that every day. That's a pretty special thing.
Yes. So kudos to you, the team back at PDMA, to put that together, and it's having it out in the field right now. It's having success where it's installed at. So kudos to you and your group there. And it's cloud-based, so you can all the data goes up to the cloud, and you can look at it from anywhere. You can be at McDonald's, like you always say, or in your backyard at your pool.
That's exactly right. And in
where most of your analysis takes place.
Exactly. Right. That's a great retirement plan. But with all the retirements happening, the nice thing is you got these people. We meet so many people who are half retired.
Remember, this came out through COVID. COVID kind of forced everybody back out of the plants into their homes. But how can you monitor the plant? This is that type of a scenario.
Yeah, it was a big filler for that void, and literally, you got a lot of people who leave with all the knowledge, and this allows them to be plugged in from the back porch of their pool enclosure. They can sign into the cloud, and basically, as long as they got credentials and they clear all the security, they can get in, look at the data, and help make a call.
Yeah, and it's pretty, I would say, comprehensive when we talk about the amount of information that it's collecting. It's collecting it from the eye. Doesn't matter if it's a upstream drive, downstream of a drive, synchronous motor, DC motor. We're going to be able to look at all that and give you some pretty pertinent information. It goes to a controller. From the controller, it goes up into the cloud, and then from the cloud, it really can go anywhere to be viewed.
Anywhere, anytime, to anyone with credentials.
Can go into some, let's say you have a different type of program like a Pi or something where the data has to come into to make bigger decisions. Can do that as well.
Requests all the time on data integration interoperability. And so having 24-hour data able to be streamed into a, like you mentioned, Pi or an asset management program, or today the real popular thing is data analytics team, right? You have these data analysts that are, experienced with data. They don't necessarily know motors, but they know trends and able to see things that are related to data. And you plug in machine learning and even AI, and all of a sudden now they're a pretty effective group helping out the maintenance team identify oncoming problems. So yeah, it's been a big deal.
Perfect. So let's talk about the case study that we had essentially you installed the eye somewhere on a pipeline. And from the onset, we were seeing some pole pass sidebands. And so in this case here, it was a 4-pole motor, 76 bars, 2,000 horsepower. So it's a large size motor.
It is big.
4,000 volts, 60
big and
hertz.
critical.
It's big and critical because if it's in a pipeline, it's used to pipe product to the next.
Well, and this was you can imagine,
like.
This is one of our first sites that we were able to install the technology. To our surprise, it was, a lot of times the petrochem industry, they're a little protective of their networks. And so being a pipeline, this was out in the middle of nowhere, right? Hours from even the where the maintenance team works out of, right? So, driving a vehicle out there, doing it once a month, once a quarter, or whatever their test frequency was.
And so that, since it was so far out, and you have to send, like you said, there's probably a full day trip, right? Because usually where you're at, 4 hours to drive out, take a test, and the test maybe is, you could do a standard test in less than 3 minutes, right?
Yeah, with the motor de-energized.
Do a PI 10 minutes.
You should within a half an hour.
Within a half an hour, you're done testing. Now you got another 4-hour drive back. Well, that's a lot of lost production for that individual who has to go out there. So in this case here, we were out in the middle of nowhere, so we were able to test out our cellular.
Absolutely. And that was two-part,
Instead of having
actually.
to use a network.
Absolutely, because not only were we out in an area where it made sense to use cellular based on communication, but the only network available out there at this pumping station was considered operational network, and there was no vendor getting on that. And so they were like, if you require a network, we're done here. So the nice thing, just like you said, simple cellular right to the cloud, and then all they had to do was basically give access to the technicians and analysts to go like they would Google. Just go look at a database.
Go look at a database. So now this brings us to, we install it, now we're collecting data, and we see a pole pass sideband.
Call it luck, living right. I don't know, but one of the multiple motors that they selected to analyze right off the bat started showing elevated, not severe, but elevated pole pass frequency sidebands.
You say not severe, but once again, it depends on the size of the asset. It depends on the speed of the asset. As to how we attack the calls on it.
Right. So we knew the bar count. This was an open bar 4-pole motor. Open bar means that you can, when I say that, if you're looking at a rotor outside of a stator winding, just sitting there like at a motor shop, if you can touch the rotor bars or see them as it goes through the iron.
So it's open bar. We're a little more concerned.
We are concerned. So we want to pay attention. We want to be on top of this, right? And so we immediately flagged it. Right, based on the amplitude, and the nice thing is we don't have to change any road trip frequency because it's testing it 24 hours a day. So we literally are watching this minute by minute.
Yes, And you can call upon to take a test whenever.
You could, like, if for some reason you wanted to stop the automation side of it and just, run a hard test, you could. That's certainly, but for the most part, not required.
So we see the pole pass, and then we go to the fifth harmonic, and we also see activity there.
Right. In previous podcasts, we've talked about the rotor specifically, and we talked about how the swirl effect, which is the fifth harmonic analysis, is a way of confirming potential rotor defects. So we follow our own guidelines, and then now that we see a problem, now we go out to the fifth harmonic, and sure enough, we're seeing these three different sideband, lower sideband harmonics. And what that does is confirm to us that the frequency we're seeing as a sideband around line frequency, the pole pass frequency as we're discussing, that in fact is an electrically induced frequency, not a machine train. I think we've talked about, C stories or case studies where we were tricked by pulverizer motor frequencies that made it look like pole pass, and it wasn't. This is not that.
Mm-hmm. And then lastly, we went into the current demodulation, and voila, we saw it there. So we see correlation. We always talk about that when somebody calls technical support. We say, well, does the online data correlate with the offline data? Do the 6 methodologies for testing a rotor bar problem, do they correlate with each other? What about other technologies, vibration or thermography? Do they correlate? And we're always preaching that or hyping that up to our customers to say, hey, why don't you try and correlate this data?
Absolutely. We consider
makes your decision making a little bit easier.
It absolutely does. We consider ourselves top tier indicators of electrical anomalies, right?
Yeah.
Vibration, wonderful technology, grandfather of reliability, right? When it comes to electrical indications, though, they're not first tier. They'll be second tier. They're still correlative, and you want to look at them. One of the things that you'll hear from tech support is, we talked about 6 methods. We don't like to make a call without 2 and maybe even 3.
Okay.
So it's a big deal.
So, okay, always it's time for the $1 million. Send the motor off.
Do we make the call?
Do we make the call? What does the motor shop say? There's always a little bit of probably a pucker
anxiety
factor. Yeah, pucker factor.
Sphincters factor.
Yeah, you're a little, is this right? But fortunately, we sent it off.
Yeah. Well, what makes it easy, though, and you mentioned it, if you had one indication, we probably would say no. In talking with the team and sitting and looking at this data together, having 3 separate positive indicators, and more importantly, we didn't just make this call overnight. This was we watched this over a period of a year almost.
It makes your life a little bit, and what's nice is you can watch it, you can see how badly it's degrading. Like if it jumped from caution to severe in a week, you might be a little more aggressive. But if you're just watching it day after day after day, and it's really not, that pole pass isn't trending too much higher.
Right.
They sent it off. The shop comes back to them and says,
picture's worth 1,000 words.
Yeah, 5 broken rotor bars.
And what was great about that, and no one can see the pictures here that are listening to us today, but to give you a description of these.
It should be posted on our YouTube channel, but it has markings.
That's true.
They put the yellow line of death on there.
Disease was pointing at the bar. So what I want you to focus on when you get a chance to see these pictures is it's an open slot design. You can physically see the cracks at the end ring. So every time this motor started and everything expanded, that crack got bigger and bigger and caused more and more problems. The issue that is so grand about the picture is in the fact that we were able to see it early and make the call was that there's no damage on the rotor slots. If you let a motor go long enough with a broken bar, it starts to send current and magnetic fields
on the top of the laminations.
On the laminations themselves, it'll burn it.
So you'll see tracking kind of on the
literally
top of those.
Burned metal, and it'll literally start to open up the slot. Well, if you let that go long enough, you can't just repair you can't just weld the in-ring.
Those are there for a reason, right? They're for I-squared-R losses, aren't they? For hysteresis or one of those losses and heating losses in the motor.
Right. You're referring to that. If you just had a big chunk of steel there, it would be a lot of current. It would get very hot. So what they do is they put small little thin pieces of steel and put them together
that are insulated from each other.
Right.
But when the current travels over, guess what?
It kind of burns that right up.
It acts like a big chunk of steel again.
It becomes conductive again, right? And it'll burn open and allow that rotor to come out. But if it gets bad enough, you can't just weld the rotor to the shorting ring at the end. You have to restack the whole lamination. Yeah. So what a great case study. We identified it, got it out, and repaired before they had to restack the rotor.
And it's always nice when you put the replacement in and it has a lower pull pass sidebands, so the work was completed as expected. And then one of the cool tools that I've noticed with the new PDM-AI is the historian, where we can now track the number of starts and stops on that asset, because that is very vital, right? There is usually a time limit before, especially large motors, where you can start and stop. So now you can start to see, is the process correct? Are we starting it and then stopping it, and then 2 minutes later we start it again? Should we be doing that? Are we allowed to do that? Of course, probably not.
Right. There are hard NEMA limits on that. And just like you said, having, the ability to see every start and know when it's starting, it's another indicator of abuse, really. It's kind of like keeping an eye on operations. If they're doing double starts or if they're starting it more than twice an hour. Now, every motor can be a little different.
Yeah, because as a technician, you get the call, hey, the motor won't start.
Right.
What happened 1 hour before?
Yes. Yeah. Wouldn't it be nice
know that.
open up a historian, which is a time series plot, and see every start and say, well, you guys started it 3 times in 15 minutes.
Last night.
Yeah. Well, the first one tripped. We tried it again. It tripped again. We replaced a fuse and started a 3rd time and it worked, or it didn't.
Or it didn't.
Well, what happens when you're heating at 100 degrees C or more on each start?
Yeah.
You're asking for trouble. It's just not good. So, you're absolutely right. The historian became my go-to plot, with the installation of the eye, because it's a time series indicator of such a variety of KPIs, the key performance indicators that our analysts make decisions with. So
moving on to another great case study that we have for the forensic review. This came to us from a utility. And trending, what the value of being able to trend it from, kind of like you always say, cradle to grave.
Amen.
Right?
Absolutely.
So this is a 6.9 kV motor, 2,000 horsepower again. So these are large motors that we're looking at. And in 01, nothing. We've got a perfectly good current signature analysis spectrum. No pull pass sidebands.
Right. Dominant line frequency with no sidebands.
No sidebands. Everything is good. So the first time you test it, everything looks good. That's a great baseline.
It is. Baseline is such important. I can't tell you how many times you walk through our tech support department and you can hear them talking about, well, what, and you go look at the data and there's one data in history. And it's the one that they took after the operations complained about a motor taking too long to start or it tripped. And it just makes it hard to trend is your friend. So get that baseline as soon as possible.
Same February, we go to the 5th harmonic, really nothing going on there as well, just 2 peaks there.
Absolutely. Yeah.
So it's not concerned about it.
It's certainly not something that's going to raise any attention. The 5th harmonic is always sort of like a secondary indicator. So we need to have the pole pass around line frequency first before we put too much weight on the swirl effect. But it's great to see that they took it and they're thinking. That's important.
Yeah. So now we go to October.
8 months later.
About 8 months later. Yes. Excuse my math.
6, 8, whatever it takes.
6, 8, whatever it takes,
356,
man.
357.
We're in for the long haul. October 4th, 01, we start to see a pull pass sideband kind of creep out. Now it's below the observe, but it's still starting. You can see it.
Right. And one of the things tech support's going to ask the owner to look at is, hey, let's compare the loads at the time, the speeds of the machine, things to make sure that, if you take it unloaded, a lot of times it can be different than a loaded. And so, we don't want you to not test any time, whether it's 50% loaded, 80% loaded, take the test when you get the opportunity.
Do we tell them at this time, since it's not really in any type of observe, do we limit this, or do we just say, let's just increase monitoring?
That's all we should do at this point, right? So, hey, you've been testing once every 6 months or 8 months in this situation.
6, 8,
maybe whatever it takes, right? So maybe increase it to quarterly. Let's get ahead of this thing. Here's the other thing we ask is, and we often don't get the answer, but we've talked about this in tips and stuff. Is the birth certificate again, right?
Yeah.
Is it an open or closed bar design? Are there lots of starts and stops? Right. The testing we're seeing here was done with a portable technology, so they don't have every start to look at. So when you get a chance, you have to take it, right? And so the more you know about the motor, the better off it is. And so every time a motor comes back from the shop, it should be, you're not just getting the bearing information, you're getting, what is the expected run out? How many bars are there? What is the open or closed bar design? These kind of things that can be hugely helpful for your maintenance team.
So we tested in '02, still not a lot of changes, still right at the observe line. And then we're also able to, in '02, we kind of put it in our demodulation spectrum.
Right, which should follow the rotor testing immediately, right?
Yeah,
if you're taking a test,
band alarm it.
Yes.
So that we don't have to rely on visual. We just put an alarmer on it. And
if it turns yellow, it turns red.
Yeah.
We want to take a closer look.
Now we get to '03 and it's above observe.
Yes, we've entered
into an area where now we might start saying, okay, let's limit the number of starts and stops on this asset if we can. Let's limit the load changes on this asset if we can.
Yeah, after 2 years, it's definitely, not only are you seeing elevated pole pass sidebands, but harmonics on both sides, on the high and low side of the line frequency.
And you're seeing fifth harmonic activity.
Which is, again, a correlating
So you
requirement.
went from nothing in '01 to now in '03, we now start to see fifth harmonic activity.
It'd be interesting to hear from the owners. How often is this motor started? This may be an annual start. Utilities don't.
It's a condensate pump, so my guess is it runs frequently, right? It doesn't do a lot.
Always, constantly.
It's a constant running because condensate pumps, as you and I both know, since we were in the nuclear field, is essentially just recycling. It's a pump. It pumps water to cool off.
And there's always water to pump.
Yeah.
It's not like it's on a float or anything. It's pumping all the time.
Yeah.
So very likely over 2 years, right, with very few starts, we can see that even that is going to elevate, problems. They don't, that's just going to go away. So they're going to get worse, and they have.
And they have. And so in '03, the pole pass sidebands are getting a little bit higher. The fifth harmonic, like we said, now there's 4 peaks there. Does that mean anything?
No, but it's just a harmonic, basically. So what'll happen, like anything, it's the same in vibration as it is in electrical. The more harmonics, the worse the problem.
Okay. Then we get to where we band alarmed on our demodulation screen. It kicked it above it.
We have exceeded the alarm set
So
point.
it's a nice visual cue to say, hey, I set it down here. It was point here. I set it 20, 30% above that. Now it's exceeded that. It's great visual to show. And now here's interesting stuff. When they were doing this and they were looking at all of this information, they were noting that bearing temperatures were normal. Oil temperatures were normal. The analysis, normal. Stator temperature, normal. Vibration analysis, normal. So no real changes anywhere else.
And this is a good sign. This tells us that, we're offering information as an early indicator, right? So would you expect vibration? At some point it will start to correlate. There's no doubt.
Yeah.
At some point will ideally the bearing temperature doesn't change at all. Even if you have, modulating current signals that are showing up as spectral plots, they're showing up as fifth harmonic. We see it in the demod spectrum. Ideally, it's not moving the bearing so much that it's creating a temperature problem. If you have a closed bar design, and there's no fear of the rotors coming out of the slot, sometimes they'll let it go way into bar failure to the point where bearings fail before the bars do. So eventually it will affect the bearings. But like I said, when it comes to electrical faults, certainly the MC Max, the PDMAI type technology, electrical analysis tools are your top tier. Oil analysis vibration, as critical as they are for the reliability program, they're going to be a second tier indicator of stuff like a rotor bar defect. But we still want to correlate them anyway. There's no reason not to. Stator temperature, you would not expect that to go up with a
unless
fault.
It's rubbing against the stator.
Yeah, once that bearing goes and there's a little rubbing, that's not good. That's never a good thing.
So you get to the picture of it, and it's always nice when you take the rotor out and it says broken.
It says broken right there.
It says
like
right on it, broken.
Advance.
It's so easy to tell where that rotor problem is at.
And again, I'll focus the reader
little
or
gremlin comes out with his little marker.
That's right. That's
little
right.
mogwai.
It's not yellow, but it still says broken. And it's not the yellow line disease, but it is a broken. You can easily see the crack at the shorting ring, and also again early enough that you will not have to restack this lamination. It's
so key when you can trend it from the cradle to the grave.
Absolutely.
Literally, don't let it become catastrophic, because those bills can be excessive.
It'll double the cost, actually.
If you wipe out a stator because the bar flew out of it, you have just taken a rotor restack and a rotor bar repair and created a stator rewind.
New rewind, possible stator stack.
You might want to just get a whole new motor at that point.
It's close. It gets
might
pretty
be
close.
cheaper.
Yeah.
All right, so that was a great trend. The next one is just in time.
Oof.
Right? We caught it before it became catastrophic.
Makes me nervous.
So this was this came to us. This was at a platinum mine of all places, 2 miles below the Earth's surface.
That's pretty exciting, really. And
that is exciting, right?
Platinum's expensive, right? And isn't that kind of?
I think gold is more expensive.
Has it
platinum
used to be?
Like platinum, I think is only at $900 or so an ounce. Gold is at $2,500 an ounce.
Just beans.
Yeah, I mean, it used to be platinum was more expensive than gold. It really was. But for some reason, now that may change, as you know, commodity prices change all the time.
Right.
But in this case here, this was product that was being taken out of the mine that was 2 miles below the Earth's surface. So what's down there? The water table. And so they had to keep the water table. This pump here was designed to keep the water table low so you could mine the mineral out.
And keep it under your mouth when you're breathing, right? That's a pretty important thing.
Well, you're too, I don't know what I can only imagine the safety drills that you had to
I would like to know that the pumps are
miles.
working if I'm underground.
Absolutely.
I know that.
Yeah, 2 miles underground
that's a long ways.
I'm not sure.
That's
a long elevator ride back up.
We have users monitoring submersibles that are 8,000.
Now maybe it's not. Maybe 2 miles is a bit excessive, but I think it was pretty deep down there.
It very likely is. Yeah,
it was deep
it's
down
impressive.
There.
It's impressive.
So the way this came to us is once again, the individual or the technician essentially using an inrush startup to do process analysis, and he saw fluctuations, not just a steady state. There was looks like a 20 amp fluctuation on.
Current. The classic Jeff Brasher process analysis tool, and you absolutely that's a significant, that's a
huge swing
fluctuation.
That's a huge swing,
and we're talking about a centrifugal pump, right? So it's definitely a big deal.
And so good. So here's some good tips for those of you that are out there that are listening to us. What we always recommend is if you see an issue, if you've got a spare motor that's in operation that you can compare the data to, why not? Why wouldn't you?
It is a key piece of information that you should not miss.
Yeah, you should not miss that. You should be able to just go check that spare motor. What is it telling you? Is it identical? Does it have the same kind of amperage swing? If it does, then maybe it's process related and it's not the rotor bar failing.
Absolutely. For those who are driving on the highway right now listening to the Todd and Noah Show,
the
spare motor is literally
taking
flat.
the mystery out of electric motors.
That's right. But the spare motor indicator it's like a flat line.
Yeah.
It literally, there's very small oscillations.
So there's zero oscillation in the spare motor. There's a 20 amp swing in the motor in question, suspect motor. So the next thing is let's do a current signature analysis.
Some more testing.
Let's look at a pole pass sideband. And we see a pretty elevated pole pass sideband.
I believe that's
in
above the
severe.
red. Yes. And here's the sad thing, and that's the first test.
That is, yes, it could have been the first test. I think they were watching it. Maybe I didn't get the data into that one, but it's definitely, it was caught. Maybe they just started testing.
I got you.
Right?
Okay.
So they brought in the technician. Hey, we want to test our assets, and then stumbled across this. Then test the spare motor, nothing there.
Way below the
Way below, no pole pass
yeah.
sideband above in the observe area. Now, they also did a rotor influence check on this motor.
Which is impressive, 2 miles down.
Yeah.
Again, you're turning the rotor at 15, I think in this situation, probably 15 degree increments, or maybe 10. And as a result, this is not sinusoidal. This is a big deal. This is a 50 hertz, like 1487
Yeah,
or
it's
something
1480 RPM, so it's a 4-pole motor, so it's every 5 degrees.
Yep.
You're rotating that motor and collecting our rotor and collecting a inductance measurement on that, and then basically printing it out or graphing it out and looking for any anomalies on that rotor influence check.
As we describe it, the qualitative indicator of the magnetic field on the rotor itself, and it is not sinusoidal.
Yeah.
I mean, it's sinusoidal, but it's way shifting right or left, and as a result, we're not getting a smooth transition.
Some of the things we're missing here, we don't have average inductance trending higher, so we didn't make a call on average inductance, but we feel like we have inrush startup that's oscillating. Right, so we've got that. We have pole pass sidebands.
High pole pass.
We've got a rotor influence check that is showing some issues. And possibly, I don't know if we looked at fifth harmonic on this or not.
We did. I'm sure of it. We should have.
It's possible.
I don't think
we pulled that into this. I'm sure we would have looked at it. But we felt like it's ready to go. This is a motor that needs to come out of service.
Yes.
It's an open bar design, and thankfully we did, because when they took it to the shop, there was 9 out of 58 bars. Almost 20% of the bars were out of the circuit.
It's getting dangerous. This is. I love this picture here where you can actually see the bar coming out of the slot. Right? It's what's wrong with this picture? Literally, the bar, it's completely broke and it's sliding up, towards the stator.
Yeah.
And here, and like we've talked about so many times before, in early detection where there's no lamination damage, not the case here. This went long enough that there's lamination damage. You can see the hot spots. Now, my guess is because the bar's sliding out of this rotor bar or rotor slot, I think that the experts are going to suggest a restacking here. Now, how do you get it 2 miles out from under the ground up? Not easily. It's an expensive endeavor.
Hopefully you have mules.
Yeah, something for sure. And
I don't think you want to be taking it on a pallet. You think you got forklifts down there?
Thousands of. Yeah, no, I don't have none of those.
I don't want to be riding up an elevator with that size motor.
Oh my gosh, I can't imagine.
That's a lot of weight.
Ideally, they would have caught this before 9
Hopefully
of
they have a
58
service
bars.
elevator.
They got to.
Don't you think?
Every movie has one.
Every movie has a
If it's
service
in a movie,
elevator.
it's got to be real.
It's got to be real. They should make a movie out of that. So now this next case study that we're going to dive into and do a forensic review of is a little bit late in the ball game. And when I say late, we've gone well below the nameplate speed. Late. Okay.
To make it harder to detect, actually. One of the things that we worry about is if you go so late that the motor operates outside of even a normal parameter, it can actually mislead the analyst.
Okay.
Because you stop looking. You're just like, it can't be running that slow.
Yes.
So you stop looking in an area that you need to look at.
Okay. So this motor had spurious trips. Plant operator was able to reset. So rather than
probably multiple times
diving in, multiple times, would run without any problems for several days, but progressively became more frequent. More of a nuisance.
I always wonder, was it a reset once? Was it a reset, a bump test 3 times, and then after that it actually turns on?
Yeah, it's
a lot of heating, a lot of damage.
It's hard to say. The electrician did notice the motor was running with a load when it was loaded, 1,500 RPM, and it's a 1770 RPM.
Can I tell you a sea story?
Yeah, no.
This is timely.
This is timely.
Absolutely timely. Some of you guys remember the back in the day when they actually made film, for cameras. Well, we were at a manufacturing, film manufacturing, and for a demonstration of the technology. And so, as is always, when you're walking into a facility and they want to just, hey, we've got a motor picked out, we want you to test it. What does that usually mean? It usually means that there's something wrong with the motor.
Yes.
Right? They don't, if you're smart, and they were, they're going to say, hey, pick a motor with a problem. If if these guys are in town,
they're going to test you.
Absolutely.
You're in the field. You're some young hotshot back then. When you were out in the
Had
field
more hair,
30
less
years
wrinkles,
ago,
looking good.
You were black hair.
Oh, yeah.
Everything was like, what did you say, 155 pounds of twisted steel and sex appeal.
That's
so
right.
There you go. That's what Noah Bethel was. Now you go out there with a cane.
That's right. Need a walker. Carry this for me, would you?
But you're believable.
That's right. I have more credibility. We call it
much more
testing
now
cred.
You have much more credibility.
Absolutely. So here we are. We walk in and they say, hey, we got a motor for you to test. And I said, well, hey, how about if we do my favorite? Let's do an inrush startup. Since it's off, we'll just catch it on startup. And so I'm setting it up. I said, hey, They had this motor on the shop floor in a test stand with no load.
Yeah.
All right. So it wasn't even coupled to anything. And I was like, well, we still want to look at the inrush, just to show off my favorite test. And I said, well, I'll set it for 5 seconds. A 5-second inrush should be fine, right? It's unloaded, it's uncoupled. In fact, it probably only need 1 second. But he said, well, you might want to go maybe a little higher,
a little longer,
like 15. He says, no, you might want to go to 30. And I'm like, okay, you got a rotor problem. Yeah. And he's like, how'd you know that?
Exactly.
And it was shocked that we already knew this. Well, this is such a good indication, and it's way late, like you said. 1,500 RPMs on a 1770 RPM motor. That and 1770 is fully loaded, right? It should never go below.
That's 100% full load amps.
If you go below 1770 RPM, you should be at 105% or 110%. You're down at 1,500.
Right, because if it's a 4-pole motor, 1,800 RPM is synchronous speed.
Yes.
Any load added to that it's an induction motor, so it's going to be slower than 1800 RPM. So 30 RPM gap, 1770 is where 100% load on that
Absolutely.
should be. This is at 1500.
We're talking 200 RPMs lower than that.
1500 RPM, yes.
Right. And it's one of those things where if someone had told us that, hey, this 1700 horsepower motor is running at 1500, although that's so bad that although we would, normally like I did it when I went to the print company, I was like, you got a rotor bar problem. I would start to question the stator design. That's so bad. Right.
And they could get it up to 1770 with no load.
With no load. Right. This is something.
So to solve the problem, they were like, first thing that the most, so I guess it's the pain factor. What's the least painful? They decided to change the soft start.
It's never the right decision, but yeah, it happens all the time.
Even though if we would have had this data, if they would have sent this data to PDMA for us to take a look at, if we would have heard that it's 1500 RPM, and if we would have seen the rotor influence check from start to finish, and we would have seen pull pass sidebands and inrush startup and average inductance, which all of that is in this, we would have said it's not.
Stop the press. You know what else? We see this all the time. The standard sequence of what we call Easter egging. Right. And it happens everywhere. And it's because of time and money, resource, really. It's always the soft start drive first, and then the motor second, and then the cables third. The cables tend to be the most expensive time and resource. So they went down the classic road.
One thing we'll give them credit for, they had a baseline rotor influence check.
That's a big deal.
And then when you tested it a few years later, huge change. So it's the rotor bar circuit. And so when they pulled the rotors or the rotor out of the motor, it looked like half of the rotor bars were damaged. Literally half.
Yeah, we're talking an average inductance increase from 4.6 millihenries to 6.
6.
Yeah, that's huge.
That's a massive 50% change in that value. So that's where we kind of said, we didn't trust our technology. Maybe we didn't. We wanted to go the less painful route first. And then in the end, if we would have seen that data, we would have recommended this as a rotor bar problem.
Oh, yeah. And for those driving on the highway right now, the picture of this rotor, it's a closed bar design. No surprise, right? Because if it was an open bar design,
if it was open, you'd have lost a bar.
We'd have lost a stator as well. It would have dug into the stator.
But what you can see visually is the amount, all the current that's running on top of that laminations.
Literally burn. It's almost like it's burning slots into the rotor.
Yeah.
What a great picture.
All right, well, that brings us to the end of the case studies from the field, a forensic review of the Rotor Bar case studies. And if you have a case study that you'd like to share with us, we'd be more than happy to entertain it. If it is a case study, we accept it. In fact, the best part about it, we say, give us a case study. All you really need to do is give us data.
Yeah.
And if the data makes sense and a little bit of a story, and stories are great when you have a beginning, a middle, and an end, we can put the rest together. And you and I both have done this for many, many years, so it's very easy for us to do. And then we can share it out with the group. So if you have something you'd like to share with us, maybe there's something with the PDMA logo on it, a jacket or something like that.
Merch,
swag, whatever you want to call it. We'd be more than happy to get that to you. Anyways, we appreciate you guys joining us for our podcast. Hope this was entertaining to you. And if you have any questions, please don't hesitate to ask. But until then, we hope to see you next time, and you have a great day.